Okay, so I thought I'd make one last video just to go over the different ideas that we talked about. So when you're stuck on a problem, you could come to this and say, what were those ideas I have for solving exponential equations and logarithmic equations? So for exponential, first, see if you can get the bases the same. If that is possible, then that's the easiest way to do it. So it's based on if you have b to the m, if you have b to the m equals b to the n, then m equals n. Okay, so that's a nice little idea. It works really nicely if you can get the bases the same. Another idea was take the log, base b, I'll say. So you know what? I'm not going to put that. Well, I guess I am. Let me write that different. So take either a common log or a natural log of both sides. Okay, so we use that in some examples. If you've got a base 10, you're going to take a common log, otherwise natural log. Okay, and then the third idea we had here was a U substitution. Now, that has to be very specifically set up, substitution. You have to have, something squared plus, it's like A something squared plus B something has to be the same something plus C equals 0. And then you're putting in that U in there. So you're saying whatever equals U. Anyway, that was U substitution. That was the idea. Okay. You don't have to check the exponential equations. Okay, you can have a negative, exponent. All right, logarithmic equations. So first of all, maybe you can convert to exponential. That's usually the easiest way, and it's based on this, that if you have log base b of a to the nth, then b to the nth equals a. So I don't know, there could have been different variables, but this works. So you take the base, you go over here and get the exponent, and it equals the argument. Okay, that's the idea. And then from here, you solve. Okay, so then solve. Okay, 2, condense the logarithm. So if you have, this is going to work if you have more than one, it might work. If you have more than one log, okay, so that might not be a good way to say it because you might just have 2 logs, but maybe if you have 1 log on each side and that's all you have, then you can use the next idea. So that's not necessarily always going to be the way to do it, but like if you have 3 logs for sure, but you could do it with 2 logs. It just depends on what they give you. Okay, so maybe something condenses. All right, 3. Oh, let me just review those properties that we use. We have the property that if you have log base b of m plus log base b of n, you can write that as log base b of m times n. Okay, so you put it back together as one logarithm. And the other one is if you have log base b of m minus log base b of n, that equals log base b of m over n. Okay, so and I keep talking about which properties they are, and this was property 5 and this was property 6. Okay, so that's an idea. Then we had the idea, the one-to-one idea. And so that says if you have a log base b of m, and it equals the log base b of n, then you can just pop out those logarithms. Then m equals n, and then you can solve from there. Okay, so most of the properties we've reviewed probably in this section, but just in case, here are the properties. I'll just write them all out for you. This will be another little review thing. So property 1 says if you have log base b of 1 equals 0. Property 2 says if you have log base b of b, that just equals 1. Property 3 says, this is the one we use, I think we use it a lot, log base b of b to the x, that equals x. And when the base of the logarithm matches the base in the argument, it just equals the exponent. The other one, I don't think we've seen this one today, but it's if you have b to the log base b of x, that equals x. So I'll just put property 5 here again. It says log base b of m plus log base b of n equals log base b of m n. And you can write it the other way. It goes both ways. So log base b of m minus log base b of n. Did I put a minus sign up above? Yeah, okay, just checking. Equals log base b of m divided by n. So those were when we wanted to condense things. And then 7, we did use this in one of the examples, but if you have log base b m to the p, then you can bring that exponent in front and write it like that. So that allows you to bring the base down in front. The other one is the change of base property. We didn't use that. We could have done that on some of the examples, but and they hyphenate this. Okay, so the change of base says if you have log base b of m, you can split that into 2 logarithms with division, and you can have any base you want. Now, we usually either want a common log or a natural log because we're going to put it in our calculator, but that's the change of base property. Okay, so those are a review of all those properties.